Welcome back to Geometry, Chapter 8, Section 3 in this book. And what we're talking about today is similar polygons. And remember, this is versus transformations. Transformations is where you take a shape and you move it somewhere else and it has the same size and the same shape. But if something is similar, it's only the same shape, not the same size. So here we have two shapes that are supposed to be the same, just one bigger than the other. You might have to use your imagination, but imagine they're both the same shape as a baseball diamond. Alright? So, a couple of things about it. One is how you name them. You name them making sure that you have corresponding ones in the same order. So like I started here with J and went J, K, L, M, N. J, K, L, M, N. So if I named this one saying it's similar, that little curvy thing means they're similar. I have to start with the corresponding corner and go the same way. S, T, U, V, W. S, T, U, V, W. One time I had a kid who thought you put them in alphabetical order. No, they're in order of which ones are the same, which ones correspond, okay? So if these are similar, then angle J will be the same measurement as angle S. K will be the same as T, L will be the same as U, V, 1, 2, 3, 4 will be the same as M, 1, 2, 3, 4, 5, and N, 1, 2, 3, 4, 5 will be the same as W. Now the side lengths are different, but it being the same shape gives it the same angles. Okay, and so the angle J is the same as S, etc. Also, the line JK is not the same as ST, but it's similar to ST. And KL is similar to TU, UV is LM, VW is MN, and NJ is similar to WS. They correspond. Also, you can do these lines, and if you do the ratio of the lines, they're equal to each other. So JK divided by ST will give you the same fraction as KL divided by TU, as LM divided by UV, etc. You just have to make sure that if you're putting the big shape on top, you continue to put it on top, and the little shape on bottom, you put it on bottom. But you can put these links in these fractions and reduce them, and they'll give you all the same fractions. Let me show you what I mean. Here I have two similar, is my question, are they similar? Yes. I have what appears to be two similar shapes. Their angles are the same. X goes with Q, Y and R are both right angles, S and Z are the same, and W and P are the same. I know the lengths of this one, it's 15, 6, 9, 12, and this one is 10, 4, 6, 8. Are they similar? If they are, putting these as a fraction should give me the same fraction over and over again. So these two sides correspond. So I say 15 is to 15 divided by 10. If I reduce it, it is 2/3. Well, how about this one? 12 and 8. 12 and 8. See, the big one's on top, the little one's on bottom. Well, that reduces to 3/2. How about this one? 9/6. Oop. 3/2. And how about this one? 6/4. One more time, 3/2. Yes, this one is similar. Is it similar? Yes, it is, because it gave me all the same fractions. Okay, so here's an example problem with this. There's somebody who has a little picture, we'll say it's of a smiley face, and they want to blow it up to a poster. The ratio of the sides of the picture is it's 5 on the length and 3.5 on the width. And we know the width of the poster we want is 16. So that's the bottom part. So we've got the big shape bottom part is to the little shape bottom part, as the big shape X side part is to the little shape side part. And how do we solve it? We cross multiply and solve for X. 16 times 5 on one side, 3.5 times X on the other. That's 80. Equals 3.5, divide both sides by 3.5 because X is not alone, and you get 22.85 ... So it needs to be about 29 inches on this side, I don't think you would do this problem. I think you'd like blow it up where you don't get some weird little fraction where it's off and your picture looks distorted. Just saying. Alright, so here we have two similar shapes, that one and that one. And this side is 10, that one we don't know. This one's 15, that one's 6. It turns out, just like how if they're similar, all their sides make the same fraction. If they're similar, their perimeters will make the same fraction too. So all their sides make the same fraction, and so do the perimeter. So we can find out what that fraction is. These two sides correspond. So I can say 16, let me say it right, 15 is to 6 as 10 is to x. And I can cross multiply and find out what x is. So 15 times x and 16 times 10, 6 times 10, 6 times 10 is 60. So y is x not alone times 15, divide both sides by 15, and x equals 4. Now I need to know, so my ratio here of these things is 15 over 6. Do you see that's my ratio? It's the same thing as 10 over 4. And if you reduce these, it's 5 over 2. So the ratio of all the sides and the perimeters, if they're reduced, will be 5 over 2. Notice that I wrote it 15 is to 6. You could also do it 10 is to 15 as x is to 6. You can either say the one side of the big one is to the other side of the big one, as that side of the small one is to that side of the small one, or you can do it corresponding. These ones look alike, so they can be in a relationship, and those two look alike, so they can be in a relationship. Either one, you get the same answer of x being 4. So the ratio was, for all of these, are 5 to 2, so the perimeters could be something like 15 to 20. Whatever the perimeters are, if it's reduced, it'll be 5 to 2, or 5 halves. Alright, math is great. Do your homework and it'll make more sense. See you later.